Welcome everyone. Thank you for joining today's webinar. I'm Vidya and I'm your host for today. Today's session, Impact of Wear on Quality and Output, will be covered by two speakers, Mr. Satish Kumar Hanumaya and Dr. Prakash Hadimani. Satish will give an introduction about Steer and its businesses and also cover the effect of wear on ROI and other parameters. Satish holds a bachelor's degree in mechanical engineering stream and is associated with Steer from past 12 years taking care of EPC sales for India region. Dr. Prakash Hadimani will speak about the technical aspects of today's session. Dr. Prakash is a master's in polymer science and technology and has a PhD in polymer blends. He heads the application development center at Steer headquarters in Bangalore. We also have a Q&A session. You will find a Q&A tab at the bottom of your screen. Please drop in and ask your questions about today's topic. Satish and Prakash will answer them at the end of today's webinar. Please also participate in the polling questions at every break. We'll have 3 such questions and we'll really appreciate if you can respond to each one of them. Without further ado, let's now go over to Satish to commence today's webinar.
Thank you, Vidya. Good afternoon, everyone. Welcome to our webinar on impact of wear and quality and output. In today's webinar, we will be covering majorly on wear and its impact in the extruder, because in current date, wear is very important parameter in terms of defining performance of extruder. Before we go into the actual topics of our today's webinar, I would like to briefly introduce about our company Steer. Steer started in the year 1993 with the manufacturing of spare parts for other OEM extruders such as elements, barrel, shafts. Subsequently, from 2004, we started manufacturing our own extruders, and currently we have sold almost 850 extruders globally. With a market share of almost 60% in India, we are a very well-known brand in India for making extruders. We are a technology-driven company where a lot of emphasis goes on to the making new technologies, new developments in the field of compounding. We have filed almost 100 plus patents which are at different level of approvals. And we are one of the global leaders in terms of technology development in the field of compounding machinery. And we have our own special material grades for making elements, making shafts and barrels. And of course, one more major important point that I have to stress here is we are the only machinery company in this sector which has like end-to-end solutions from making tool steel to extruder. Majority of the operations or product what we do is in-house. So with this, we have a lot of control over quality. In today's webinar, we will be focusing more on wear and its impacts. Of course, our purpose is to create a technology that effectively transforms and functionalizes materials in plastics, pharma, food, nutraceuticals, biomaterials, and biorefining. We have completed 27 years since our inception. These are all our core people. Dr. Babu Padmanabhan, our MD and Chief Knowledge Officer, founder of our company Steer Group, is a technocrat, a very well-known name in the compounding industry. He has contributed to almost 60 plus patents in design, manufacturing, MOC, and he is a creator of disruptive continuous manufacturing technologies, which are used in various applications such as pharma, food, pharmaceutical, and etc. Subodh Jindal is our global CEO. He has almost 14 plus years of experience in handling businesses for P&L responsibilities. He has handled businesses such as material science, life science, market models such as B2B, B2C, and also he has handled franchisee businesses with the different skills and complexities. He has handled these markets. He is a Six Sigma black belt holder, and he has a strong process orientation towards any manufacturing technique. Sanjay Shah is our Chief Business Officer, who is leading our India, SAR country, MEAT, as well as Europe business. He has experience of almost 30 plus years in the field of raw materials. He has experience in machinery and also additives. He has handled a lot of different business development activities, sales, project planning, investment during his tenure of last 30 years of experience. Industries what we serve. Of course, polymer is our major industry where majority of our revenue comes from, followed by pharmaceutical, food, and also we produce machines and spare parts for powder coat, bioplastic, construction, one more major factor here is like apart from making extruders for all these sectors, we make spare parts for other OEMs as well. So our idea is to transplant whatever knowledge we have gained over the years to different sectors such as pharma, food, polymers, and powder coat. We are vertically integrated company where a lot of emphasis goes on into like making parts in-house. So we do this with the help of our state-of-the-art facilities or manufacturing sites which are located in Coimbatore and as well as in Bangalore. In Coimbatore, we have our own foundry to produce tool steel, and also we produce barrels, elements, gearboxes in our Coimbatore facility. In Bangalore, being an head office, we have a manufacturing site to produce elements, shafts, as well as main extruder is produced in Bangalore. With the combination of these two facilities, we produce our own proprietary metallurgy that we call it acryloi. We make element barrel shafts out of it. We make gearboxes, feeders, vacuum stuffers, panels. We have 3 different extruder platforms, Omega, Mega, and Alpha. And also we have process centers to develop pharma and food grades. We also undertake plant engineering projects for plastic, pharma, and food business. Steer is an Indian company with global presence. So we have our own offices in 4 different countries. We have our office in Japan, we have our office in US, we have our office in China, and also Bangalore, India being the head office, this is one of the global office. And in all these global offices, we have our application development center where we have kept our R&D machines to cater customer demands and their requirements. We have our 2 different manufacturing sites. One is located in Coimbatore and another one located in Bangalore. 10 satellite offices are there globally in various countries. We are 500 plus employee company. We are, as I told you before, we are technology driven company with 100 plus patents, which are at different level of approval. And 850 extruders we have already sold globally. Apart from like in India, we have sold in almost 50 plus countries. We have almost sold 1 million elements globally. And one more major salient factor is we have a database of producing spare parts for other OEMs, which are in the quantity almost of 6,000 plus. It is global supply. Extruder processing zone snapshot. We hold a 20% market share in EPZ spare part business, not only in India, it's global market leaders. So we are one among the top 5 extruder spare parts producer in the whole world. And as I mentioned before, 6,000 plus extruder database is available with us. So if customer has a requirement of other OEM spare parts, they can give the requirement with the specification we can produce, with, of course, with validation and verification. We have our presence in almost 50 plus countries. We produce, this is the EPZ capacity, spare part capacity, what we have in our plant. We can produce 72,000 elements in a year. We can produce 22,400 barrels, 1,200 shafts of different sizes. We have our wide range of MOC grades, such as corrosion resistant grades, powder metallurgy, wear resistant grades, crest welded, surface coated. Acryloi is our proprietary MOC where we produce for wear application as well as corrosion application. And our range is very big. Starting from diameter 10 to 300 mm, we can produce spare parts such as element, barrel, shafts. And whatever new development or advanced materials we develop, will be using these 4 different global application development centers, which are located in India, US, Japan, and China. Apart from providing new development and advanced material solutions, we do trials for customers before ordering of any machine. If customer wants to develop any new product or if they want to validate the existing material, they can come here and take a trial. After that, they can order the machine. Apart from doing these trials and new product development, we also provide a testing, characterization, and validation support for our customers. With this introduction, I would like to pass on the session to Dr. Prakash Adimani for actual today's webinar topic. Over to you, Prakash.
Yeah, thank you. Nice introduction about Steer and functions. Thank you so much again, Satish. Okay. Today I'm going to, we just going to discuss on the wear pattern on twin screw extruder. When you do compounding, okay, it had different polymers and fillers And when you do the processing using twin screw extruder, what is the effect of each zone? Because there is a screw to barrel clearance, how it affects and how the wear pattern changes, and that leads to the throughput, okay, final application also on the mechanical property. I'm just start with the introduction. When you do the compounding requires polymer to become soft and viscous under heat and shear. Okay, to achieve a required of mixing and dispersion and form a homogeneous mixture. Any polymers, it had a solid polymers in the form of pellets and in the form of flakes, and there are various powders enter into the twin screw to form a compound. It convert into compound using a mass, using it's very short time to form a mass, because if you apply heat, the mass has to convert into a very short time, and volume result into massive transfer of mechanical energy. Because when you add these three ingredients, pellets, filler, and it mixed together by external heating with shear, the mass will form. It's a fraction of 3 seconds and 4 seconds. That has to convert. The mass has to convert completely into the homogeneous form. That massive transfer formation mechanical energy. Okay. During this process, the material may be abrasive or corrosive, such as we use many additives, glass fiber, filler, and calcium carbonate and silica. These are materials in the form of abrasive and corrosive. When you talk about the wear during polymer compounding, the phenomena that is extremely prevalent in all the section of the screws in the twin screw extruder due to the contact between screw to screw and screw to barrel. The action of process of the material on screw and the barrels. Okay. When the process starts, it becomes fast, medium, and slow rate, okay, of the wear pattern. The wear pattern will not be uniform throughout the system. It will be sometimes faster, depend on the final application, or depends on what the material you use. Maybe is abrasive material, then the wear pattern will be faster. If you use a mild or medium fillers, then the wear pattern will be medium. And this mechanism results into serious consequence in controlling the quality and product. Today we are going to discuss how the wear, okay, the impact of wear on output and productivity, and also the quality. Okay, we will just introduction. We finish the introduction, we start with the first zone, okay? Because in the twin screw, there are many zones: the feeding zone, mixing and melting zone, again, the side feeding, so that you feed material, and there also it's a mixing, melting takes place. If you have another next zone, the second zone, if you have some more materials like to add more filler, then that also had a distributive and dispersion mixing, vacuum, and the metering section. First, we'll discuss about the feed zone. What is the phenomena happens in the feed zone? In the feed zone, there are many types of polymers. Maybe the polymers will be crystalline or amorphous in nature. Okay, crystalline, you talk about polyamide, nylon 6 and 6,6. Amorphous polymer, you talk about polycarbonate, and there are, okay. And also there are recycled PET, okay. These materials results into abrasive wear due to the contact between screw to barrel. The feeding abrasive fillers, okay, such as titanium dioxide, calcium carbonate, and the talc. Okay. If you feed from the intake to the purpose of improving dispersion, that causes abrasion. Means it's abrasion of the surface due to the particle flow. What is the effect? When you feed it from the intake, what's the effect? The loss of feeding capacity or the intake capacity drops, and also the hopper start flooding. We experience many of the compounding, we say, oh, hopper started flooding. It's maybe many reasons. Hopper started flooding, maybe the lower bulk density of the material, or maybe wear and tear in the first screw section, maybe because of the abrasive nature of the filler. We could move to the compression. We call it the melting zone. It includes compression zone and melting zone. These two combine, it's in the next to the melting zone. What is the phenomena? Okay, it starts the compression and kneading elements experience high level of mechanical flexing. Okay, when the compression starts, the kneading block level high level of mechanical flexing and start rubbing against barrel surface and causing abrasive wear or adhesive wear. This phenomena happens in the melting zone. The flow of abrasive particles with the melt during the melting and mixing cause high level of abrasive wear, because the particles flow that it contributes melting and mixing, but it also high level of abrasive wear taken place. The presence of moisture, because some of the hygroscopic materials like the polyamide and some of the fillers also hygroscopic in nature, they absorb moisture. Okay, when the presence of moisture, other free radical causes corrosion. Okay, these are the material causes corrosion. What is the effect happening in the melting zone? The loss of melting capacity drops because of the wear and tear and also because of corrosion and adhesive wear. Okay, that's significant impact on compounding process because melting drops suddenly. Okay, that is effect of due to the wear. Now we move to the next section is mixing and melting zone, because when after polymer 100% molten and we try to feed talc from the side feeder, and then we need again mixing, melting has to take place in that particular section. So that what is the phenomena happens there? The mixing, melting takes place, but the feeding of abrasive materials, some fillers from the side feeder reduce the screw to barrel contact, wear, and while the wear occurs due to the presence of abrasive materials. What is the effect? Loss of dispersion, because wear and tear takes place. Due to that, the loss of dispersion and mechanical property, loses the mechanical property. The back venting starts flooding. Okay. That again blocks and then it reduces the final throughput. Now, the important the zone is the vacuum zone, because this phenomena it contributes both vacuum and also metering zone. When in this phenomena, the flexing of screw in the metering section lead to abrasive wear, okay, in the end zone of the extruder, because material start stagnate there and it start flexing the screw. Okay, that's in the metering zone. And also it forms a corrosive wear due to the presence of monomer moisture, and other volatile organic compounds. Corrosive nature comes in the vacuums because some of the unreacted monomer during the polymerization, if you didn't apply and remove completely, then it adhered unreacted monomer, okay, and also some moisture and volatile organic compounds due to the corrosion way takes place during that section. What is the effect happens? Porosity. If you plug, for example, if the vacuum didn't work, it didn't function, when it stops, then what are the effects happens? The effect is the porosity in the final product, voids in the final product, that leads to reduce your mechanical property, okay, lowers the mechanical property, and that appears the final compound due to many reasons, okay. When port get blocked, because if it is a wear and tear takes place in that particular section, okay, the vent starts flooding and block the complete zone. Vacuum level drops due to the inadequate sealing, the efficiency at the filled zone, okay, prior to the vacuum zone. And pumping action reduces the metering zone to forms way. Okay, now I have given you small introduction about, okay, introduction about how the polymer behavior, how the polymer phenomena in each section in the twin screw extruder. I have covered intake, melting mixing zone, side feeder zone, and then vacuum and metering section. Now, we are going to talk about on the case studies on the impact of wear on quality and product. First, we discuss on the quality. Later stage, we will discuss on the output. In the impact of wear on the quality, we have selected 3 zones. One, we selected, you see here, this selection was compression and kneading section, we selected. And second zone, we call it as kneading. Third zone, again, one more kneading section. Okay. In this DOE, we selected first kneading, okay, second kneading and third kneading. In the first, the combination of this DOE, first kneading, no OD reduction, and followed by second and third. In the first, when you put on the screw and the process, no OD reduction, as it is, if it is a 40 millimeter extruder, okay, 1200 RPM, 40 millimeter extruder, the screw diameter is 39.7. Per side, the screw to barrel clearance is 0.15. Okay, that is the actual. There, no OD reduction. We started and demonstrated. And second, we reduced the OD in the first section, 0.6 millimeter, both the side, per side is 0.3 millimeter. And in the second section and third section, no OD reduction. When it comes to the third level, 1 millimeter, both the side, per side 0.5 millimeter in each side, screw to barrel clearance, OD reduction. Second and third zone, no OD reduction. When it comes to the fourth level, 1.5 millimeter OD reduction for both the sides, 0.75 millimeter per side from barrel to the screw clearance. In the second kneading, third kneading, no OD reduction. We started to reduce the OD reduction when the first kneading section 1.5 millimeter both the side, 0.75 each side of the barrel elements clearance. We did OD reduction, and 1 millimeter OD reduction for the first kneading section that shows each side 0.5 millimeter. Okay. In the third section also 0.5 millimeter per side. When it comes to the sixth level, 2 millimeter OD reduction means per side 1 millimeter in the first kneading section, and in the second kneading section 1.5 millimeter both the side. That shows the 0.75 per side of the OD reduction. It is similar to also in the third section. In seventh level, okay, set of 7th trial, 2.5 millimeter on the both the side means one side 0.25 millimeter OD reduction per side. It is similar 2 millimeter in the second kneading section, 1 millimeter per side, and third section also 1 millimeter per side on the screw and the barrel OD reduction. In the eighth section, 3 millimeter both the side, 1.5 millimeter per side in the each section. In the case of second kneading and third kneading, 2.5 millimeter on both the side, and also similar to 1.25 per side millimeter section. And we have selected 4 applications to understand the wear pattern, understand the study of the how the wear phenomena, okay, happens when you do the OD reduction using this application. What is the behavior? Okay, what is the impact on the quality, or what is the impact on the mechanical property and the throughput? We have selected first application, polypropylene, 40% talc. Okay, we use the split feed method, means polymer fed from the intake and remaining 40% talc from each one side feeder 1 and side feeder 2. And LLDPE blue pigment 15:3, 25% and plus 30% CaCO3. It's a combination, all three put together in high-speed mixture, made 100% premix fed from the intake. And the third application, LLDPE and blue pigment, it's a monopigment, 40% pigment, 100% premix in a high-speed mixture. We fed from the intake through the screw extruder. And the fourth application, LLDPE carbon black, 50%, 100% premix in the high-speed mixture and fed from the intake. And we use 2 setup, okay. One is a split feed method for a polypropylene talc, polypropylene from the intake 30 and remaining 10% from both side feeder 1 and side feeder. And when you use 100% premix, color master batch and combination of carbon black and the calcium carbonate fed from the intake. This was the 2 setup we used for this study. Okay, first we'll talk about PP talc, 40% weight pigment. Okay, 40% talc we use, no OD reduction here, split feed method. We observe the tensile strength of the mechanical property. Without OD reduction, we are getting 24.25 megapascal in tensile strength. In the first kneading section, we reduce 0.3 millimeter per side. At that 0.3 millimeter per side, no difference in the tensile strength. Second section, again in the first section kneading, we reduce 0.5 millimeter per side. Both the side, 1 millimeter, no difference. We didn't find any difference on the change in the mechanical property. Up to here in the first section of the kneading, 1.5, slight reduction, but it's negligible. We didn't observe because that shows the polymer. It's very important when you feed polypropylene or any polymer, it has to molten 100%. form a homogeneous dispersion, so that when you try to feed the talc from the first side feeder, it has to wet and disperse completely. If there is no wear and tear, then it maintains the mechanical property. That is the sign we are getting. When you started reduction, OD reduction from the first kneading section is 1.5 millimeter, mean 0.75 per side. Also, second kneading and third kneading section, it's a 1 millimeter OD reduction, means per side is 0.55. Okay, 0.5. There is a slight reduction on tensile strength, but the large section, if you see that the first kneading section 2 millimeter and second and third kneading 1.5 millimeter, slightly reduced in the mechanical, means the tensile strength dropping down. That gives an indication there is a dispersion is hampering, means the dispersion is not good up to the mark, because the polymer is not melting properly, and also the particle has to disperse completely by up and shear, because that is not effective. That is why we are getting the reduce in the tensile strength. Okay, in the same application, PP, talc 40% weight percent. Okay, no OD reduction. The flexural modulus, okay, flexural modulus, it's maintained without OD reduction. It is constant, and up to the first kneading, not much changes, and up to here, we are finding a difference in the after first kneading. When you do the 1.5 OD reduction, slight reduce in the stiffness. Okay, stiffness is very important, okay, for the automotive industry and the flexing. And the second one is the first kneading 1.55 millimeter and followed by second kneading and third kneading, we observe 1 millimeter reduction, OD reduction. We did means per side 0.5 millimeter. In the first kneading, if it is 1.5 millimeter OD reduction, per side is 0.75. There is slight reduce in the flexural modulus. That gives an indication the dispersion is hampering. Dispersion is not happening. It could be maybe the polymer is not melting properly, and also the talc is not dispersing. The particles are not dispersed and distributed in the polymer matrix. And the first kneading section 2 millimeter and followed by 2 and 3 kneadings, the 1.5 millimeter reduction means 0.75 each side. There is slight reduce in the mechanical property, and followed by flexural modulus reduces. And also when it goes to the finally, we see that the first kneading 3 millimeter, second and third kneading is 2.5 millimeter. Okay, it shows 1.25 per side reduction. The slight reduce in the mechanical property, means the flexural modulus. Now, we are coming to the polypropylene tall for the impact strength. Even in the impact, up to the first kneading 1.5 millimeter, the second and third kneading shows 1 millimeter reduction, not much change in the reduce in the impact strength. The impact strength started reducing after first kneading, second and third kneading. The first kneading 2 millimeter means per side 1 millimeter, and second and third kneading shows 1.5 millimeter both the side. If we say 0.75 per side, okay, that is a slight reduce in the impact strength, and impact strength is maintaining. And in the case of first kneading 3 millimeter means per side 1.5, 1.5, okay, and the second and third kneading shows 2.5 millimeter for the both the side. Now, LLDP blue, 40% pigments, monopigments. Here, the dispersion is very important. Dispersion quality has to play a role, not on the other properties, but the dispersion has to. Without OD reduction, this is standard 1.5 gram per gram, per gram, sorry. And first kneading, and also first kneading 0.6 millimeter both the side, and the first kneading 1 millimeter, 0.5 millimeter each side, and the dispersion quality poorer in the first kneading when we have 0.75 per side. Then it started losing its dispersion quality, and up to the, and at the end, the first kneading shows 3 millimeter OD reduction, means 1.5 per side. Okay. Second and third kneading 2.5 both the side, that shows 1.25 per side. We are getting the dispersion quality filter pressure value of 6.22 bar per gram. Now, we are still on the LLDP blue, 25% calcium carbonate, and on the other one is calcium carbonate and the 25% blue. This combination, without OD reduction, we are getting 1 bar per gram, and slowly up to first kneading 1.5 millimeter, means 0.75 per side, and it's followed by second and third kneading section 0.55 per side. It is dispersion quality was good. And where you lost the dispersion quality at the end of you say the first kneading 2 millimeter, means 1 millimeter per side. Second and third kneading of 1.5 millimeter both the side shows 0.75 per side. The dispersion quality poorer and poorer. In the case of carbon black, it's 50% carbon black. The filter value without OD reduction, approximately 2 bar per gram. And slowly, it is gradually increasing the dispersion quality poorer at 3.5. And in the case of first kneading 1.5 millimeter, if you say 0.75 both the side, second and third section, we're getting 6.2 bar per gram. It's very poor quality of dispersion. And afterwards, in the case of first kneading 2 millimeter and 2.5, 3 millimeter, that shows the filter pressure value was tripping because its dispersion quality was very poor. That gives an indication.
Thank you, Prakash. Here is our first poll question. Please select your answer from the list of options displayed on your screen. Considering the impact of wear on output and quality, as well as cost of elements, will you like to discuss with us and identify best time for elements replacement? You have about 30 seconds to answer this question. All right, 3, 2, and 1. Let's see the results. 84% says yes, and 0% say no. 16% of them says maybe later. Also, if you have any questions on the ongoing webinar, please drop into the Q&A tab at the bottom of your screens and kindly ask your questions. All right, let's go back to Dr. Prakash to continue with the webinar.
Thank you, Vidya. Now, we are going to, on the second case studies, we have selected same application in the second case studies. Here, we are going to discuss impact of wear okay, impact of wear on the output, how it affect the throughput. In this case, we have not did the OD reduction section by section, means zone by zone, where we, in the earlier study, we did zone by zone, okay, first needing section, second and third. In this case, to understand the output, understand the final output, we did the OD reduction from intake to end. How the output will behave. We have used same 40 millimeter extruder, okay, LOD of 52 we have used, and we have selected 3 application: polypropylene, talc 40%, split feed method using 2 side feeder, LLDP blue 25% and 40% calcium carbonate combination, 100% premix, fed from intake, LLDP, carbon black 50%, 100% premix in the high-speed mixture, fed from the intake. We have selected 3 OD reduction in this case. 1, we have started no OD reduction, understand the study the effect of screw elements wear on, no OD reduction, 1.5 millimeter OD reduction, both the side, means 0.75 per side, and the 3 millimeter OD reduction means both the side, means 1.5 per side, from starting from intake to the end. And it is including all conveying everything, okay? In the earlier section, conveying elements, we have not did the OD reduction, only the kneading and compression section we did. But in this case, to understand final throughput, output, and we did the complete OD reduction, even including and kneading, started 3 combinations, 1.5 millimeter and 3 millimeter OD reduction. If you see, first the split feed method, polypropylene fed from the intake and talc from both the side feeder. No OD reduction we observed the throughput for the 40% talc. We observed 200 kg per hour and 600 RPM, 300 kg per hour in 800 RPM. It's a 40 millimeter extruder. And after doing OD reduction, 1.5 millimeter OD reduction, and slight drop in the throughput, 170 kg per hour, and in the 800 RPM, 250 kg per hour. After doing the OD reduction, the third case, 3 millimeter OD reduction means 1.5 millimeter per side, we are getting 120 kg per hour in 600 RPM, 170 kg per hour in 800 RPM. That shows if your polymer is not 100% melted and mixing, there is reduction in the throughput. Means if 1.5 millimeter OD reduction, 600 RPM, 0.75 per side, there is a drop on the output 15%. In 600 RPM, again, if you do the 300 millimeter OD reduction, means 1.5 millimeter per side, 40% drop on the output. In 800 RPM, similarly, in 1.5 millimeter, 16% drop, okay? And in the 800 RPM, 3 millimeter OD reduction, both the side, 43% drop on the output. If you come to the SME, no OD reduction, 0.17 kilowatt per kg, kilowatt kg per hour, sorry, kilowatt kg per hour. And at 800 RPM, same, not change. Only change in the SME here at 3 millimeter OD reduction, 1.5 millimeter per second. There is an increase in the power consumption, 0.2 kilowatt kg per hour. If you calculate drop, the increase in SME, 5.8% at 600 RPM, 17% and 600 RPM for a 3 millimeter OD reduction, 5.8 increase in SME, 800 RPM for a 1.5 millimeter OD reduction. Per side, 0.75 millimeter OD reduction. 17% increase in SME at 800 RPM and 1.5 millimeter per side OD reduction. When you talk about 100% premix of blue pigment with a combination of calcium carbonate, no OD reduction, we are getting at 600 RPM, 85 kg per hour, 105 kg per hour at 800 RPM. After reducing the OD 1.5 millimeter, 0.75 per side, we are getting 58 kg, 71 kg respectively. In 3 millimeter OD reduction, both the side means 1.5 millimeter per side, nothing, it's 20 kg per hour and 27, means that shows the efficiency drop drastically, means because we have done even conveying all elements also, OD reduction, it reduced drastically. The drop of OD reduction or drop of output, 31% in 600 RPM, 76% drop in output at 600 RPM, 3 millimeter OD reduction, that shows 1.5 millimeter per side. And 800 RPM, you will see 1.5 millimeter both the side, 32% OD, 32% drop in output, 74% drop in output at 800 RPM and 3 millimeter OD reduction. SME, again, similarly increasing very high. In 600 RPM, 1.5 millimeter OD reduction, 58%, and 600 RPM, 3 millimeter OD reduction per side, 1.55. The increase in SME, 122%. Similarly, 800 and 800 with 1.5 millimeter and 3 millimeter, and the increase in SME is 133% high. Finally, we come to the carbon black, 100% premix method. No OD reduction, we got 200 kg per hour and 600 RPM, 220 kg per hour at 800 RPM. There's a slight drop, almost half drop. When you do 1.5 millimeter OD reduction per side is almost 0.75. We drop up the output 120 kg and 100 kilo. And in 3 millimeter OD reduction, 1.5 per side, it's 20 kilo. It's drastically reduced. 20 kg, where is 20 kilo? And no OD reduction, it's almost 200 kg. And 40% output drop in 600 RPM at 1.5 millimeter OD reduction. 90% output drop in 600 RPM with the 3 millimeter OD reduction. 800 RPM with 1.5 millimeter OD reduction, 50% drop in the output, and 100% drop at 800 RPM with a 3 millimeter OD reduction, means 1.5 millimeter OD reduction per side. It's 100% drop in the output, means nothing, it's zero. And if you calculate on the SME power consumption, you see 600 RPM, 1.5 millimeter OD reduction, there's the SME increase 121%, and 600 RPM 3 millimeter OD reduction, 232% increase. And in the case of 800 RPM, 1.5 millimeter OD reduction, 97% increase in the SME. Now, finally, we conclude the impact of wear on quality and output study were carried out for OD reduction and also no OD reduction. And we started from 0.6 millimeter both the side. If you calculate 0.3 per side, 2 to 3 millimeter OD reduction. And also we studied different zone and also 100% premix, the OD reduction from intake to the end. of the OD reduction using omega-40 H class. And to increase wear, reduces tensile strength, flexural modulus. If you say first kneading zone of 2 millimeter and second zone of 1.5 millimeter and 3 kneading of zone 1.5 millimeter in the split feed method. The increase in wear reduce dispersion quality. First kneading section zone of first kneading zone and also 2 millimeter, it is acceptable. And second kneading zone of 1.5 millimeter and 3 kneading zone of 1.5 millimeter in premix method. And when it comes to this is what we discussed on the quality. And when it comes to the output, the split feed method showed 1.5 millimeter OD reduction, shows 15% output drop compared to the OD reduction of also 40% output drop in 3 millimeter OD reduction. The premix feed showed 35.5% output drop in 1.5 millimeter, means per side is 0.75 millimeter, and 83% output drop in 3 millimeter OD per side is 1.5 millimeter compared to the no OD reduction. I think second.
Yeah. Here is our second polling question. Please select your answer from the list of options displayed on your screen. Are you interested in understanding more about MOC offerings from Steer for your application? You have about 30 seconds to answer this. All right, 3, 2, and 1. Let's see the results. 87% say interested, 2% say not interested, and 11% say maybe later. Also, if you have any questions on the ongoing webinar, please drop into the Q&A tab at the bottom of your screens and please ask your questions. Let's go to the final session of today's webinar. And now Satish will take us through the effect of wear on ROI and other parameters. Over to you, Satish.
Seems like some technical issue. Output as well as quality.
Okay, thank you.
Sorry for the interruption. Thank you, Prakash, for your insights on effect of wear on quality and output. At the end, I would like to cover effect of wear on return on investment and other parameters. First, we will discuss about effect on productivity. What are the productivity effect wear has on in the extruder? First, to start with, the excess power consumption, specific mechanical energy input is more if you have more wear in the extruder. So you need more power to produce the material. So, and again, extra cost for you. You need extra manpower because of where output will be reduced. So because of output reduction, you need more man hours and plant hours to produce the required quantity. And also because of less output and productivity, you will lose revenue and also profitability in your business. And also you cannot meet your customer commitments in time because you need more time to produce the product. So I would like to explain with simple calculation how this productivity effect wear is causing in this case. Let us assume 500 kg extruder, you have output of 500 kg. Conversion cost of from raw material to finished product is, let us assume 10 rupees per kg. And in that 80% will be your operating cost. It's an assumption what we are making. So output is 500 kg and conversion cost is 10 rupees. 6,000 hours in a year. That is, I have considered 20 hours in a day, 25 days in a month, and 12 months. So put together, total conversion cost will be multiplication factor of all these three: output, conversion cost, and number of number of hours in a year. So you will have conversion cost of almost 3 crores in this case. And total income, 20% margin, that is 80% if you, is your operating cost, 20% is margin. Then you will have 60,000 as your income. Sorry, 60 lakhs as your income. Similarly, if the wear happens and if it has an effect on output and quality, if you are getting a drop of 10% output because of this wear, and also if your operating cost is increasing by 8% in our assumption, keeping 10 rupees as operating conversion cost, this is the calculation. Output 10% drop means 50 kg will be reduced. So we will get 450 kg per hour. Conversion cost remains same at 10 rupees. Number of hours remains same at 6,000 hours. Total conversion cost will be again multiplication of all these three. Now you will have 2 crores 70 lakhs as your total conversion cost. So in this case, total income will be around 32 lakhs 40,000. So if you compare both the cases, if you have a 10% drop and a drop in output as well as 8% increase in operating cost, you will lose almost 27 lakh 60,000, which is very substantial amount. So instead of losing this amount, what we are suggesting is please invest on elements on periodical basis so that you will have more output and also you can get more benefits with very less cost. So now I will cover effect on quality. What kind of effect wear will have on quality? So you will have to do a lot of reworks to match the benchmark quality of your customers. And you have to do multiple passes. Instead of getting the quality, same desired quality in single pass, you have to do multiple passes. And also you will face issues like dispersion in color master batch, as Dr. Prakash said. Mechanical properties such as tensile strength, flexural strength will not meet the benchmark. And also you may have to use additives and extra additives and process stabilizers to match the quality standards, which will be additional burden for you. If you quality is not good, aesthetics of end product will not be good. There will be white patches, color dull. So many other complaints will come from your end use customers. And your customer may have to do a lot of reworks on end use products in order to match the required specifications. And also you will find dimensional variations in molded parts when it comes to automotive and appliances. It's very big concern for your end use customers. Finally, what effect on your end use customers? So if you are aware and if your quality is going down and output is less, what kind of effect it can have on your customer? Definitely, you will lose your customer confidence because of quality issues as well as not supplying the parts on time. You may lose the order because a lot of quality issues which are coming from this wear. And also, someone's loss is others' gain. So if you are giving product with not matching the quality specification, other player in the market may come and you can capture your market. And also operators or production people, their morale will go down because continuous problems in the machine as well as output or quality will not boost their morale. And finally, consistency and performance of compounds will not be met for your customers. So that will be a big concern again. Okay, finally, why you need to go with Steer? What are our strengths and competitive advantages that our customer gets? To name few, you will get a wide range of MOC options for your applications, such as wear resistance grades, corrosion resistant grades, based on your application requirements. Powder metallurgy, of late we have developed this. If you have a high specific torque machine with high speed and output, we will give materials with the powder metallurgy technique having soft core. And we can do crest welding elements also for different applications. We can do surface coating such as nitriding, titanium aluminum nitride, tin coating. So many coatings are available based on your application requirements. A proprietary MOC, we have our own grade called Acrolite, as I told you. We have developed this internally, and it is performing very well with wear resistant applications as well as in corrosion resistant applications. These Acrolite MOCs are outperforming even powder metallurgy and any given grade available in the market globally. And you will get a lot of range. So if your extruder is starting from 10 millimeter to 300 millimeter, in this range we can produce elements, barrel, shaft, dies, couplers, adapters, plugs, so many other parts. So we have the range. So whatever may be the size, you will get the solution from Steer. And another advantage from Steer is like we have our almost 6,000 plus extruded database. If you have machine from Europe or US, Japan, you just have to tell the name of the machine with whatever specification is there in the machine. Based on that, we can develop and supply the element barrel shafts to you. Of course, before supplying, we will validate and verify the dimension and other things. Lead time, since like we are vertically integrated company and we have our own in-house design capability and manufacturing capacity, so you will get products in a very reasonable amount of time. It's not so high compared to competition. Quality of product will be ensured like in all stages. It is not like lot QC inspection we do. We do inspection of all the parts stage by stage. If manufacturing has 10 different stages, at each and every stage quality is checked, and finally all the quality parameters at the end also checked. And OEM grade product means if you have a machine from Europe or US or Japan, whatever product you are getting from OEMs, you will get similar products in terms of dimension as well as in quality and MOC. This is one more biggest advantage what we provided to you. Finally, what I can summarize is that you will get value for money from our side, highest quality product with reasonable amount of money. These are all your advantages, what you get from. We'll go to poll 3 now.
Let's see what we have on the third poll question. Please select your answers from the list of options displayed on your screen. Would you be interested to work with us to understand impact of wear on ROI for your particular application? You have about 30 seconds. All right, 3, 2, and 1. Let's see the results. %78% say yes and 22% say maybe later. So we have reached the end of this session. Thank you, Dr. Prakash and Satish. On behalf of Steer, we thank all of you for participating in today's webinar. Let's now move on to the Q&A session. Since we have a time constraint, we'll be taking fewer questions. We already exceeded the amount of time we had for this session. So the rest of the questions will be answered offline. So let's see what the first question is.